Hello guys, welcome back. So here we have another question on network theory from GATE 2016. The Z parameters of the two-port network shown in the figure are Z11 equal to 40 ohm, Z12 equal to 60 ohm, Z21 equal to 80 ohm and Z22 equal to 100 ohm. The average power delivered to RL equal to 20 ohm in watts is dash. So this is not the maximizing power theorem. Here RL already they have given and they are asking us to find the average power delivered to RL. So what we need to we need to find V2 and I2 and then multiply them, or just finding one of them is sufficient because we already know the relation between V2 I2 is related by RL by Ohm's law. So now we have the two-port network. Two-port network Z parameter, what we have, V1 V2 is related to Z11, Z12, Z21, Z22 into I1, I2. So this is nothing but 40, 60, 80, 100. Very easy, right, to remember. 40, 60, 80, 100 into I1, I2. So if you have to write it in the normal form, it is 40 I1 plus 60 I2 and V2 is 80 I1 plus 100 I2. But if you also see from the external circuit, in the external circuit, how are V1, V2 related? I1 is nothing but 20 minus V1 by 10 ohms, right? And what is I2 or V2 is RL, V2 by RL is flowing in this direction, right? So I2 RL will be minus I2 RL. So if it is a positive current, it should be flowing in this direction. Since it is flowing in the other direction, it should have a negative sign. So now we have these four equations. And we have four unknowns. Because RL is already known. So we can solve and find either V2 or I2. If we find any one of them, it is sufficient for us. There is no necessity that we need to find both. So first I'll substitute this in this equation. So this is nothing but minus 20 I2 because RL is 20, right? So substituting 4 in 2. So minus 20 I2 is equal to 80 I1 plus 100 I2. So minus 120 I2 is equal to 80 I1. So I2 is equal to minus 8 by 12 I1. So this again in fourth table it becomes 2 by 3. So I2 is equal to minus 2 by 3 I1. So let's take this as, or we'll get I1 in terms of I2. So I1 is equal to minus 3 by 2 I2 because we want to eliminate other variables and let's say we want to find I2. So this is 5. And now V1 from 3 what we have? From 3 we have 10 I1 is equal to 20 minus V1 and I1 is minus 3 by 2 I2. So 10 into minus 3 by 2 I2 is equal to 20 minus V1. So this is 15 minus 15 I2 is equal to 20 minus V1. So my V1 is equal to 20 plus 15 I2. So this is 6. Now I have I1 V1. This I can substitute in 1 to find my I2. So 5 and 6 in 1. 1 is nothing but V1 is equal to 40 60. So 40 I1 plus 60 I2. V1 is 20 plus 15 I2. I1 is minus 3 by 2 I2. So this 2 and 40 goes away, 20. So here we have minus 60 I2 plus 60 I2. So this becomes 0. So we only have 15 I2 is equal to 20 minus 20. So what is my I2? My I2 is nothing but minus 20 by 15. So my I2 is minus 4 by 3. So now what is the power average? So this is I2 going in this direction. So irrespective of the sign, this will be 4 by 3. So irrespective of the sign, power is always consumed by RL, and so average power delivered to RL will be I square R, I2 square into RL. So which is equal to 4 square by 3 square into RL is 20. So which is equal to 16 by 9 into 20. So this is 320 divided by 9. So 3 times 27. Remaining is 5. 50 is 5 times. 45. Again 50 is 5 times. So it is 3.555. Sorry, 35.555. So your power is 35.56 watt. So your answer is 35.56.